Hello everyone, thank you for coming to this session. This talk performance improvement of filtering foreign tables using subquery for Postgres. I will talk about Postgres subquery with foreign tables, performance problems and how to solve it. It is experimental, so I'd be happy to hear your opinion. This is today's agenda. Firstly, I would explain overview of this session. Secondly, what is problem in parallel query when getting large-scale records? Next is how to solve problem of efficient filtering foreign tables using subquery. Next, I will show you about evaluation of our solution, comparing conventional and our proposal solution. Lastly, I would like to conclude of this talk. Firstly, I will talk about overview of this session. Before getting into the main subject, I would like to introduce myself. I live and work in Japan, Kawasaki. Kawasaki is nearby Tokyo. I am an engineer at Toshiba Corporation, Advanced Corporate Software Development and Technology Department. I am developing with Postgres since 2017. And I am developing some FDWs. FDWs is foreign data wrapper I will explain later, and custom Postgres. So this is talk overview. Currently, storing data is increasing. The amount of data store is increasing, and the size of data centers and the size of data stored in database are increasing. This talk describes performance improvement of Postgres filtering foreign tables using subquery. If the foreign table is over the network, it will take a long time to transfer them from internal table. We improved pushdown of in-class filtering. We confirmed performance improvement of up to about 50 times in the test environment. Okay, next I will talk about issue of filtering foreign table using subquery and in-class. Firstly, I will explain future of foreign data wrapper. It is FDW. Other data source can be defined as foreign tables in Postgres and can be accessed by SQL in the same way as Postgres tables. FDW is implemented with extension, which is installed in Postgres for each data source. Officially, there is a Postgres FDW to connect to other Postgres. Some users have created different types of FDWs. Some FDWs have pushdown capability to execute instructions such as where classes or aggregations on the data source's side. And Postgres FDW can push down some filter and aggregation. This is issue thread. Postgres has two foreign tables. Both of tables have very big data. If user executes the where class and in-class use the subquery, such as following tables and SQL, current Postgres will generate a join plan for this query. However, join processing becomes wasted for some cases such as count aggregation. I will explain currently Postgres ordinal processing with example. In this example, Postgres has two data sources. Data1 tables has 10 million records. Data2 table has 1 million records. SQL is there. Firstly, Postgres gets data from data source 1 and data source 2. Postgres does not get all of data because projection and filtering are pushed down. For example, the table of data 1 gets only C1 by projection. The table of data 2 gets by where class it is filtered. After getting the data from data sources, Postgres executes join. If planner can select a hash join, the amount of computation is only n. But in the other case, so for the example, it is select the sort merge join, the amount of computation will be increased. More preciously, depending on the type of join, only one table is got in its entirety, and the join is executed while fetching the other table. But for the sake of the simplicity, I explained it this way. This slide explains the need for join. For example, as shown in the figure on the left, join is necessary when columns from both tables are needed for the result. However, if the result requires columns from only one table, as shown on the right, there is no need to join. But current Postgres executes join in both of cases. Next, I will explain the solution for the case shown on the right. Okay, I will talk solution of efficient filtering foreign tables using subquery in this session. So this is overview of solution. We improved the in-class changed by result of subquery. When a subquery with an in-class is executed, the subquery is first executed and result is used to create the contents of the in-class. In addition, pushdown in-class with expanded values from subqueries can result. This will prevent unnecessary data transfer. Improved plan is applied when both of tables are foreign tables and the result requires only columns from one table. I will explain step of this solution in next. This is step overview. Step is 5 steps. First step is confirm query. If the query is a pattern that does not require a join, it means use in-class and both tables are foreign tables, and final result use only one table columns and other condition. Second step is execute only subquery. Third step is create modified query with second step. More preciously, update Postgres query 3. Fourth step is execute modified query. This query is pushed down to the database. Last step is get result and return to user. I will explain each step in detail. For example, is same as before for data sources, tables, and queries. Firstly, we confirm the query. More precisely, we confirm the contents of the query tree after pass phase. The contents to be confirmed include the use of foreign tables, the in-classes subqueries and as a result, confirming that the required columns are not spread across multiple tables. Next step is, if it matches the current case, execute a subquery and get the results. It's subquery only. Next step is the original query is rewrite to. We rewrite the query tree. The rewrite includes rewriting the subquery of the in-classes to the result of the subquery just obtained. Next step is the rewritten query is executed. In the figure, the contents of the four classes are pushed out. Whether or not the contents are pushed out depends on the data sources and FDW. Example, Postgres is pushed out, but in the case of file FDW can use CSV file. All data is retrieved. Last step is get result of modified query. In figure case, if the request is select count, it returns one record only. Depending on the query, of course, multiple cases will be returned. But basically, the number of cases retrieved will be less than the of retrieving all cases for join. Next, I will explain how we modified Postgres. Firstly, I will explain the Postgres basic flow. This slide is Postgres basic flow. There are four phases: parser phase, relator phase, planner phase, executor phase. As SQL to create a query tree. Relator phase, extension, view and rule feature, and update query tree. Planner phase, create and select best path and create plan tree from best path. Executor phase, execute. Execute means get record and calculate the plan with plan tree. This is Postgres basic flow. Next, I will explain what to modify. History, we modified rewriter. We add confirm phase in rewrite process. More specifically, after rewrite process, confirm query tree. If query tree includes subquery, which use foreign table and in class, then execute only subquery firstly. Next is, if a condition is matched, execute in a query tree with only subqueries. Firstly, create a plan tree from the query tree and execute the plan tree in executor. It is only subquery. Next is, when the execution phase is finished at subquery, it comes back to rewriter. Explain here in step 3, the query tree is rewritten using the result of the subquery. Last phase, create a plan tree based on the rewritten query tree. Execute the plan tree using executor and return the results to user. Next, I will explain the evaluation. Okay, this slide is environment of evaluate. Machine is one Postgres and two data sources. Data sources are all Postgres, and I used Postgres FDW. Postgres version is 13 and detailed machine specs as written. I use AWS. Data is one is 1 gigabyte tables and the other is 200 megabyte table. 1 gigabyte table is 10 million records. One record size is about 100 byte. 100 megabyte table is 2 million records. One record size is about 100 byte. So I will explain the query. Query is following. So I measured subquery and query with varying results. The number of subquery results was adjusted so that changing the SID condition would change the number of subquery results. The overall query result was assumed to be 10 times the subquery result. Subquery result is 1, 10, 100, 1000, 10,000, and 100,000. This is result. Normal is not modified, ordinary Postgres. Improved is our modified Postgres. The result is improved is so very fast. I will explain detailed results. For subqueries with 1 to 10,000 results, the results were almost the same. Before the modification, so normal case took about 70 seconds. The modified improved took about 1 second. This speed up is about 50 times. So improved is very fast. This slide describes the result of the 100,000 case. In normal Postgres took more time, about 2 minutes. Join operation took a lot of time in 100,000 case. Improved took about 50 seconds all of the time. Especially update the query tree and get data from data source 1. It means get final result time was increased. But normal case takes about 10 times longer than improved. Next is detail of time for Postgres basic flow. This is amount of subquery result is 1000 case. Pass, rewrite, and run times are fast, but execution time is very slow. In contrast, improved result in almost the same pass time, but rewrite and run time is slow. But execution time is very fast. This is because in improved rewrite, the subquery is executed and the query tree is updated using the result in the plan. But it is clear that improved is faster through the entire process, even at some cost in rewrite and plan phase. Next, I will talk about the summary of today's. This is conclusion. So currently, Postgres does not execute subquery first, and not create queries using the results. We developed an efficient way to execute a subquery first and push the new condition using result down to data source. About 50 times faster in our environment. The difference is even greater depending on the size of both tables. Currently, it only supports in-classes. It may be applied in the same way, such as when using the with class. We will fix it. And last is, so does it know other better ways? So expected for start procedure. So we know it is easy to execute using start procedure. We know very well, but some situation and user cannot use start procedure in security and there's knowledge. Please let me know. Okay, that's all. Thank you for listening to my session.